Okay, so hello, my name is Moulay Zaidane, and I'll be presenting on how we customize LLMs through Airflow at Laurel. And so the funny little anecdote was I was just grabbing dinner with a friend of mine a couple of days ago, and he works in real estate here in the Bay. He was like, "What brings you here?" I was like, presenting at Airflow on how to customize LLMs, and he was like, "What are LLMs?" And it was just a refreshing perspective because he works like in real estate, building a lot of the infrastructure all around, but like didn't have a sense of what LLMs were. And it's just a good reminder that when good infrastructure is built, you don't necessarily need to know like the use cases that it will allow. And honestly, like this is a lot of the theme for us like at Laurel. Like Airflow is not necessarily designed to be like a core ML orchestration pipeline, let alone specifically for LLMs, but it's proven to be very effective for us, specifically for like personalization and cost-sensitive training. And so that's what I'll be presenting here. And of course, a lot of our work uses LLMs, but we also use other kinds of models, and we'll be discussing about all of those things holistically. So yeah, as I mentioned, my name is Moulay Zaidane. I'm a data scientist at Laurel. I joined as a founding member of the AI team, and so I've like gotten to touch on like everything from like model like design, training, deployment, monitoring, orchestration, the full like end-to-end stack. And so, yeah, we'll be like sharing a little bit about our journey. So first of all, just like what's the problem, the company, the solution, how we like decided to have Airflow be the foundational piece of our training workflow. And then we'll like jump into like some more specific use cases around personalization and our approach to like cost-sensitive inference. So problem, the company, the solution. First off, do any of you have a sense of what this device is or what it does? No takers? So this is a timekeeping device. So depending on what angle you rotate it on, it'll keep track of time for one of the specific projects that you're interested in. And this device was just developed a couple of years ago, and point to say is that keeping track of your time is a challenging problem, and people are trying to innovate it and approach in so many different directions. Now that is not what Laurel's product is, but timekeeping is a serious business challenge, specifically in part just by its magnitude. About 20% of the US GDP works by keeping time through for billing. And professionals with high hourly fees are expected to have very precise and accurate time tracking. If any of you have had to deal with lawyers, you know what I'm referencing to. And at a broader level, time is just our most precious asset, and so it's valuable to understand how it's allocated just from a business perspective. And so a little bit about Laurel, we're a Series B company, about $55 million raised to date. Our primary product is around automating timesheets. So we want to shift away from the manual process of keeping track of time. And we started off with lawyers. Why lawyers? Because they have very high billable hours, and they have very strict requirements on how they keep track of time, and very stringent security. And so the idea was that if we can solve the problem on hard mode, then we could scale to other industries, and that's what we did by signing EY and partnering with them, working in the accounting vertical. And the fun little note about our company too is that about 2 years ago we kind of restarted from scratch in terms of our product rebuild, and one of the core motivations there was to really up level our machine learning infrastructure, and leveraging Airflow was one of the core decisions that we made there. So concretely, what does the product look like, and what does it take to keep track of time? Well, for one, this is a screenshot of our application. You see that to keep track of your time, you need to understand which projects you're working on. You need to identify how many hours you've worked for each of those projects. You need to write a description for what you've done. And then finally assign sets of codes for each project to keep track of that. And so of course, we offer timers for users who want to be able to keep track of that. But as you can imagine, some of our users work on over 50 projects per day, and can be very hard to keep track of. Some lawyers are required to bill in 6-minute increments, because an hour of a lawyer's work can be worth thousands of dollars. And so 10% of that matters. That's our way of keeping track of time manually. But a lot of the innovation at Laurel is about how do we automate this entire process. And so here, as you can see on the right side, we have activities that are collected through our Laurel Assistant. And so the Laurel Assistant connects in different ways. One, just through the cloud via calendar, email integration, Zoom, Outlook, and we keep track of all form of work activities. And then we have an assistant that's on the local device that keeps track of documents that you might have worked on, browser extensions, and all forms of work that you're doing on your device. And so this gives you almost a log of all of your history, and this can range anywhere between like 100 to like thousands of activities per day, so like start and stop time and all the metadata associated with the work that you've performed. Now, hundreds to thousands of units of work can be like very overwhelming to parse, and so that's why we provide grouping. So we group all of those like units of work into like a more intuitive notion of what work is. You can imagine like you're moving between like VS Code, Stack Overflow, and maybe ChatGPT to do your task, but in the end, you're just doing one thing, which is coding. And so we just combine all of those things into meaningful units. Then we classify them into the specific project that you're working on, assign the sets of codes that the users expect, and then finally we generate a description automatically to just remind you of like what it was in a way that is compliant with all forms of like guidelines that are expected. And so as you can imagine, to do each of those tasks, we have like a suite of models for each of those steps, and so keeping track of all of those models, managing them, retraining them is what Airflow really helps us with. So as I mentioned, it's really like the core of our machine learning engine, and so I'll be discussing a little bit about this. So first, I want to share a little bit about the enabling constraints that we have as a business and how they motivated us to like leverage Airflow. So for one, privacy. One of the constraints that we got very early on working with lawyers is that they really didn't want us to train models using their data and then like serve those insights to any of their other customers. They were like, we provide you the data, but you can only train for us and serve the inferences to us. And so that required like very clear isolation for model training. Second, we have a very strong data drift problem. So as you know, once you train a model, over time, the model drifts, they become stale, and you need to like retrain it to keep it up to date. In our specific case, people work on new projects every day, new clients every day, and so just keeping track of that, being dynamically adjusted is like super important. And so one of the constraints that imposes is that we need to be able to retrain models very frequently, sometimes daily. Another one is varied user behavior. So some people keep track of their time contemporaneously throughout the day. Others wait the end of the week, some the end of the month, some the last minute of the month. And so it means that we have like very varied usage pattern, and so that's an important variable when like designing our system and like adapting to user needs. And finally, we're in like users' critical path. They rely on us to get paid, and so we need to make sure that our data is accurate, reliable, and like very responsive to any form of like changes in context they provide. And so a friend of mine was saying that like in order to use Airflow, you need to earn the right to use Airflow. And so before using Airflow, a lot of the things that we were doing were just like manually training a model for each of our customers. And say that it took just like even a couple of hours to train a model for a customer and a couple of hours to deploy it, we'd have to go and do it for every single customer. And so just you'd have a new model version, you'd have to go and like do it for every single one. It would take like weeks to just like go over the entire stack, and then like new model improvement, just do it again. And so a lot of like the work that we ended up spending was just like not on high added value model improvements, but just like giving people the latest version. So that was one of the key challenges. Anytime you have a new feature, in order to backfill all of that, extremely complicated. If you wanted to run any form of simulation, that was also like a significant challenge. So all of those things are things that like encourage us to like use Airflow, and it's been like a great experience since. And so at a very high level overview, once we re-architected our system, we kind of like standardized like our modeling approach. So every single model, we divided into like these like distinct components of like datasets generator, having a model like training or fine tuning, and then finally an evaluation and deployment step. And so by isolating each of those different steps as tasks and combining them as like a DAG, it allows for like a very modular process and the ability to really change models like very quickly, safely, and iterate on new versions. So for example, on the dataset generator side, say that we get a new business requirement, which is even within this firm, these sets of lawyers or accountants are not supposed to have their data intermingled. That's very easy for us to do. We can just go change the dataset generator policy, and then all of the rest of the DAG can like remains unchanged. Similarly for model fine tuning, if we have just one new model idea change, we can experiment with that while keeping like all of the rest of the pipeline like stable. And finally, same thing for evaluation. One thing we noticed was that the performance between our like models using cross-validation was quite different from the performance that we had in production. And so we had to actually use temporal cross-validation in order to validate before pushing to prod. And so just by having like all of our models share the same evaluation task made it like extremely easy to just like substitute it and then have like all of the other DAGs like pick it up and leverage that benefit. And so again, to showcase like the versatility of like this approach, here are like 3 distinct features that are using very different kinds of models in the back end. It's purposely chosen to cover kind of the whole like range of like history of the NLP. So one of like our auto-completion framework actually uses like Bayesian probability and Markov chain. So we're going all the way back to the late 1800s. And actually the reason why we're using that is because LLMs can hallucinate, LLMs can leak information, and in our use case, that was just absolutely not acceptable. And given that the descriptions user writes are usually only like in the range of 20 words, there are some generic sentences like email description regarding opposing counsel, just like extremely easy to learn and localized. And so there, the DAG is extremely useful. We can just run it on every single day for a user, learn what are these like sets of like predicate and suggestions, store that, and like leverage it for inference. We train our own like Siamese neural networks, and this is more for work code prediction. So trying to understand like how does a particular firm want to classify their work internally for record keeping. And their DAGs are like extremely useful. We just like run them like on a weekly basis, keep track of that. And if there is any like new model, like data dump that comes from a customer, it's very easy to just like manually retrigger and like be adapted to that. And then finally, for the like newest fancy like LLMs, DAGs are super useful for experimentation. And so we wanted to like experiment with fine tuning, and we're just able to like run that quite effectively and like progressively use it even for inference. And I'll be going into more details on like how we also use Airflow for inference. So first off, Airflow for personalization. So a lot of the AI strategy at Laurel is like leveraging the fact that we have humans in the loop. Every day, users perform their work. Laurel suggests entries that might represent what they've done, and then the timekeeper reviews, edits it as they see fit, and then submits the entry to their client. And so we learn from that. And so like the real competitive advantage of Laurel is like getting access to this data, learning, and providing this iterative feedback. So being able to personalize the experience as quickly as possible is like one of our key differentiators. And so how does that like really relate to Airflow, and how does Airflow enable that? Well, for one, like as data scientists, we often think of like our models as like the individual like model weights or the model artifact that is generated. But from a user's perspective, when they think of AI, they really think of something that is like learning continuously. And a neural network, like it doesn't learn from every single inference that it performs. It learns when it is trained. And so from our perspective, we really look at the machine learning system holistically, not just as the model itself, but how often it gets trained. And so a lot of the questions that we have to ask ourselves is, how often should model retraining happen? Which subset of data does it need to be considered for every single run? Or like, as we're trying to improve the modeling experience, do we need to invest more on like increasing the retraining cadence, or do we just need to improve our models themselves? And so similarly to the way like models have this concept of hyperparameters, the parameters that cannot be learned in the neural network, it's like how many like layers do you have or how many nodes you have in a particular layer. Well, similarly here, like our entire like machine learning system infrastructure has these hyperparameters. And in the context of Airflow, these just become like DAG parameters. And so it's like very easy for us to kind of like experiment. How often do we need to increase retraining cadence and how to do so? So that's for like one piece of that. Another one is just, we train like in some cases like more than one model per user. That leads to a lot of models, and the point is actually that that can be computationally efficient. A lot of the questions we get sometimes like, isn't that too expensive to generate? And actually not necessarily. For one, when you train models on a smaller subset of data, for one, we can always leverage like large language models or embeddings that have been like traded from a lot to like not start from scratch. And then by constraining the problem space to just focus on a particular user, you can actually reach convergence like much faster. So like that's faster training steps. And then it's true, storage grows when you have more models, but these days you don't have to train like the entire sets of weights from scratch. You can just kind of like add the Laurel matrix or additional fine-tuning layer on top of your networks, and you can just like save those artifacts as part of your model prediction. And then finally, yes, at inference, we need to be able to retrieve those models effectively. And here, like a lot of what we use is like efficient caching and like dynamic model provisioning. So like we know like which kind of users are going to use the application when, and like provision models accordingly. A specific example here is grouping. So every user thinks of their work in different units. So here, for example, we see one group that involves like a meeting, documents, some Google search, and another meeting. Some people will just think of that's a whole set of one thing, performing an interview, doing the background check, and all of that. For other users, they actually have to build like every single meeting or email separately. And so being able to understand what it means to have one unit of work needs a lot of adaptation at the user level. And so what is our modeling approach for this? Well, it's a series of steps. One, we have a model that's a similarity classifier that determines whether two activities are similar to one another. Second, we take all of that information and build a matrix out of that. And so each activity pair has like a score of how they're similar to one another, and we use that as an input for our clustering algorithm. And then we prune any activities that are likely outliers. And finally, we have another model, which is our confidence classifier, which we use to determine whether this unit of work is actually relevant to the user. Maybe it's their personal meeting, maybe it's a medical visit that like doesn't necessarily fall within like their workday. And so, as you can see, we have multiple models per users. There's possible dependency within those. And Airflow is just great at managing that. Like we can like train each of these models separately, depending on user action. If a user releases a lot of work, then we know that we just need to update our similarity classifier and run the DAG for that. In parallel, if the user is rejecting a lot of the entries that we're presenting, then we know that we need to adapt our confidence classifier, and we can just trigger that DAG independently. And of course, if there's any dependency between how those models are trained, that's also like very easy to capture in Airflow. So that's a lot for personalization. And then the final piece that I wanted to show on is cost-sensitive inference. For all of you who've like used LLMs in production, you know that those things are not necessarily the cheapest. And so performing inference using Airflow is also something that we've been doing. And so, as we mentioned in our problem, like a lot of the work just happens as a stream. Users are constantly working, we're constantly collecting activities. And we have to present that work intuitively to the user, but we also know that the users are not continuously in our application. Some are, but a lot of them just come at whatever cadence, week or month or day. And so that gives us an opportunity to adapt our predictions to match their behavior. And one other element that Airflow has been very useful for us from an inference perspective is that it's allowed us to like release models safely. So here, for example, like what you see in the bottom part is the live inference step. So when activity arrives, we featureize it, we store it, we generate that matrix necessary for grouping, and then we generate the clusters, and then the front end can just like access that. But once we wanted to upgrade our model to like more expensive ones that leverage more LLMs, there was a question of like, how is this even going to scale? And so we actually started performing inference initially on Airflow on an hourly basis. And the idea was that like users like might not get the newest version if they're coming in within an hour of the work performed, but if they come after, then they'll have access to that. And so progressively what we could do is see that matched, that we could handle that scale, and then progressively increase until we felt confident we could reach real-time performance. So Airflow allowed us to like progressively scale our model inference in this way. But additionally, even once we realized that we were able to serve models fast enough, there was a question of, do we need to be performing these expensive LLM calls on every single new activity thousands of times per user per day? And what we discovered was like, not necessarily. What we can do is like perform the cheapest models that are like fast, synchronously, and that over time, as we get more context, a better idea of what the user has done over the day, we can start calling the more expensive ones on a DAG. And so the users end up getting a consistent experience, but also the more time passes, they have this feeling that the system like learns with them, understands the better context, and we can offer them the best experience when they actually come in and see the app. And so here, like again, like diving down deeply to the specific use case. So as I mentioned, here are like the groups we're discussing, but we also generate descriptions for them. And that's a lot of like where like the generative components of LLMs arises. And so in order to do that, what we do is we have a retrieval-augmented generation approach. So we need to get like firm guidelines, previously written narratives, and like the new work activity, fill all of that into a prompt, and then summarize it. And again, as I mentioned, instead of running the call like every single time a new activity comes, which could be 1,000 times a day, we just run it on whatever cadence matches how often we know this user is going to show up in the application. And that leads to like orders of magnitudes of saving. I think back of the envelope calculations, we were saving more than $40,000 per month on like LLM calls just by like reducing the cadence. And so that's one. We consistently provide descriptions, and we match the inference schedule, yeah, exactly to to their billing schedule. And it's also easy for experimentation. One use case where we've been like exploring is fine-tuning these models, and like Airflow just makes it like very easy. We train the models, like save the new API endpoint that should be used, and access that. So yeah, as a summary, Airflow has been a very powerful orchestrating tool for all of our machine learning workflows. Keeping each component modular is like great for iteration, safe releases. And one of the insights was that like we really need to think of our entire like machine learning system as our models, not just the individual artifacts. And there's a very neat parallel between DAG parameters and like model system hyperparameters. And then yeah, adapting inference to the cadence of usage. So make as many calls as really necessary by the user. And yeah, amongst other benefits for like backfills, simulations, and all sorts of things.